anything. So dv over dt
equals k L minus v in parentheses the L minus v. V of 0 equals 20.
When v is 0. No, v is 0 when t is 20.
I think so, and then L is 24.81.
Yes, 24.81. It's. Oh yeah, we did this problem in class. You want to do it?
Yeah, I just wanted to talk through it again.
Yes, of course. Okay, so the idea here is to separate the variables. This is not a variable, so let's put it in from the beginning so it's not confusing. This is a constant. It is not given to us. So this is 24.81 minus v. Good, so see we have v here and v here. So somehow this piece has to end up on this side, and this piece has to end up on that side. So first let's cross multiply, because I think that this is better and easier for you to understand what I'm doing. I didn't mean that. I just said I can't talk and do things at the same time anymore. Or I contradict myself, I guess. Sorry about that. Just kidding. Okay, so what I would like to do here first also, factor out -1. So I have dv equals -k v minus 24.81 dt. As you know, we like a clean ship. So then now I divide both sides by this piece. So now finally, dividing both sides by this, it ends on the right, on the correct side with its dv together. Good. So now we integrate. So the left-hand side is natural log of v minus 24.81. The right-hand side is -k t plus a constant c. If you differentiate this, you get that. If you differentiate this, you get that. You know there is an imaginary e here, as we know, the base of natural log. So e to that will be the absolute value of v minus 24.81 equals e to this piece times e to this piece, which, you know, you can leave it as is, I'm fine with it, but it's normally denoted by c. So then v minus 24.81 will be plus or minus c e to -kt. And I just moved this here, and I got v. So v equals plus or minus c e to -kt and plus 24.81. Now, the problem was telling us that v0 when t is 20. So 0 when t is 20. So this is plus or minus c e to -20k. We could have we could have determined c from here. That's even better than from here. So I don't have to have that plus or minus. Okay, so I should have done that. I should have stopped here for a moment and just plug in a 0, which would have given us the natural log of 24.81 with the absolute value is positive, and this is 20. So let's do that. So natural log of 24.81 equals -20k plus c. So then c is natural log of 24.81 plus 20k. So if that's the case, then we can determine this constant easier, because now e to c will be e to this times e to 20k. And this is 24, you know, remember the rule, e to natural log of a number is just that number, 24.81. So then e to c equals 24.81 times e to 20k. So that is the constant c. What I would like to mention here is, I believe, I don't remember the exact problem, but I believe it was also telling us that this number is the limiting value. So if it's a limited value, it cannot be lower than that. That's, I don't remember as I said. Was it a limiting value? Was it, what was it saying about 24.81? I don't remember. So then we have to be careful. Because if this is the maximum, then I have to use negative. If this is the minimum, then I have to use plus. So it depends on what this value represents. If it says it's the minimum value, then I have to use the plus. So minimum goes with the plus. If this is the maximum, then I have to have minus in front. We have to go back and check what the values were, what this 24.81 represented. If it represents the maximum or the minimum value, so that we know which one to pick. Is that okay? Next question. Anything else you would like to go back to?
I still haven't been able to find those problems I mentioned last week where it was like the marginal profit, but it was the like X plus a change in H. I just can't figure out what section they were in. I went through one by one in the MyLabs, and I just can't figure out which one it is. You said you thought you knew what I was talking about.
I don't think it's in the second part.
Yes, but like we discussed last time, we have to use that, like that math to do things in the second part.
I'm not sure which one you're referring. I would love to find those, but I'm not sure. Can you elaborate a little bit on the question? I'm not sure what you're asking.
You just said that you knew what I'm talking about. It's in the first part. It's just in the second, there were a couple problems like a week or two ago where it wanted us to use that as like a part C of a question.
So, like an approximation? Are you talking about?
Yeah,
Are you talking about f of x plus dx is approximately f of x plus f prime of x dx? Is that what you're talking about?
No, I'll keep digging. I can find it. I don't know where it is, but I should be able to find it. I thought you knew what it is, but it's not that. So
it's not that. So this is the marginal cost situation. This is it.
It's the one where there's like in the formula there's the triangle, like triangle plus triangle x or something, and it would be like if you made a shirt plus 2 shirts or something like that.
The delta x, like finding the x.
Yes, I was going to say that, but this is it. This is the formula.
To be fair, I don't really understand it, so if that is it, it makes
So
sense.
so if you have here, if you produce normally 100, and now you want to increase by 1, so now you want to produce 101, you're using this formula. to approximate, right? But if you want the exact, then you will have the cost of 101 minus the cost of 100 to determine your additional cost if you want to manufacture one more. So this is the exact. If you want to approximate the cost of producing an extra, then you're thinking in these terms.
Okay.
So this is the approximation. This is what I said last time, but we didn't get to work on a problem last time. But this is what we are asked. So if we are asked to find the exact is one thing. If you're asked to find the approximation, then you use this formula. So now I think this is what you mean. Is that correct?
Yeah, I think so.
That's what I thought last time as well. So
Yeah, I just couldn't, like, I was trying to look through the sections to find an example, but I couldn't, and obviously I was trying to pay attention to what you're doing.
yeah, sure. Let me take a look and see. So this is for the marginal cost and marginal revenue or marginal profit. So it's not in integration. It's not in chapter 4. It's not in chapter 3. Those are exponential and log. It's not in chapter 5 because we only had the consumer surplus and producer surplus. It's not in 5.7 because we just did that. It's differential equations. And it's not in chapter 6. So where did it pop up again in the second half? That's my question.
Yeah, and that's what I just said I couldn't find it. I know it was there because I remembered I didn't understand it from the first section.
From this,
I'll keep going through it, and
I'm looking at the reviews. Let's go through the reviews. If you want to go to page 366, let's go to the reviews of these 4 chapters. That's the easiest way. A problem should be there.
okay. And it also might have just been one weird problem, but it would have been in our written homework, so I could probably look through our written homework as well.
Okay, very good. So I'm looking in chapter 3.